Welcome to today's lesson on reducing fractions and adding and subtracting fractions with like denominators. And while we reduce fractions, we're going to look at two different ways to reduce fractions. Reducing fractions can also be referred to as lowest terms and simplest form. The first way we're going to look at to reduce fractions is using the GCF, or the greatest common factor. We talked about this in a previous lesson. Let's reduce 12/18. The first thing we need to do is make a factor t for 12 and one for 18. And we go through and we list all of the factors. 1 times 12 is 12, 2 times 6 is 12, and 3 times 4 is 12. In 18, 1 times 18 is 18, 2 times 9 is 18, and 3 times 6 is 18. Remember, if you're trying to figure out if a number can go into what you're dividing, for instance, if a 12 is divisible by a number, think of your divisibility rules. Now we need to go through and circle the factors they have in common. We see 1, 2, 3, and 6. And it's not a bad idea to go ahead and write them afterwards so that you make sure that you have all the factors that they have in common. Now you want to look for the greatest factor they have in common. And in this problem, it's 6. So 6 is our GCF, or greatest common factor. The next step is to divide the numerator and the denominator by the GCF. You can see that the GCF was 6, so we're dividing both 12 and 18 by 6. Think of this as the golden rule of fractions. What you do to one, you must do to the other. And 12 divided by 6 is 2, and 18 divided by 6 equals 3. So 12/18 in lowest terms is 2/3. When you're trying to figure out if a fraction can be reduced or not, one thing to think about is if the GCF of both the numerator and the denominator is 1, that means you're done. That fraction cannot be reduced. So just remember, GCF is 1, you're done. That fraction cannot be reduced. Let's reduce the fraction 24/72. The first thing I'm going to do is draw my factor t for 24 and 72. I have all my factors listed for each 24 and 72. Now I want to go through and find out the factors that they share in common. 24 and 72 share the factors 1, 2, 3, 4, 6, 8, 12, and 24. And the largest of those factors is 24. So the greatest common factor is 24. The next step is to go back and divide my numerator and my denominator by the greatest common factor, which in this case is 24. And 24 divided by 24 is 1. 72 divided by 24, well, if I'm having a hard time remembering what that is, I can go back in my factor t that I had, and I can see that 24 times 3 is 72. Therefore, 72 divided by 24 is 3. So 24/72 is 1/3, is equal to 1/3 when it has been reduced to lowest terms. Now let's look at our second way to reduce fractions, and this time we're going to use prime factorization. which is something that we talked about in one of our previous lessons as well. We want to reduce the fraction 12/18 to lowest terms. So first, we're going to find the prime factorization of 12. We know that 12 can be broken down into 2 times 6. We circle the 2 because it's a prime number. 6 can be broken down further as it's a composite number. So 6 can be broken down into 2 times 3. We circle both the 2 and the 3 because they are both prime numbers. Then we go ahead, because there's nothing else left to break down, and we write those circled prime factors together in order from least to greatest as 2 times 2 times 3. If we go ahead and multiply those out, we have 2 times 2 is 4, and 4 times that last 3 is 12, and we get back to our original 12. Now we're going to find the prime factorization of 18. 18 can be broken down into 2 times 9. We circle the 2 because it's a prime number. 9 can be broken down further into 3 times 3. And we circle both of those 3's because they're both prime numbers as well. There's nothing left to break down, so we write those prime factors that have been circled in order from least to greatest. And we have 2 times 3 times 3. And if we multiply it out, we see that 2 times 3 is 6, and 6 times 3 is 18, and we're back to our original 18. So we did it correctly. The next step is to compare the prime factorization of 12 and the prime factorization of 18. You can see we rewrote it in the same colors. Here's our 12, the 2 times 2 times 3, and here's our 18, the 2 times 3 times 3. What we now need to look for is we need to look for what those two prime factorizations share in common. I see they share a 2 and they share a 3. I'm not going to circle this last 2 and 3 because they're not the same in both lists. Now I'm going to move over here and I'm going to take those numbers that I circled. I have a pair of 2's. So there's the 2. They share in common a pair of 3's, and there's a 3. And I'm going to multiply them. 2 times 3 gives us 6. I'm now going to take that 6 that I got, and that's what I'm going to divide my numerator and my denominator by. 12 divided by 6 is 2, and 18 divided by 6 is 3. 12/18 in lowest terms is 2/3. And if we go back and we look, when we use the greatest common factor method, there we are with 2/3. So it works either way, using the greatest common factor or using prime factorization. Let's use the prime factorization method to break down 24 over 72. I'm first going to find the prime factorization of 24. 24 can be broken down into 4 times 6. Neither one of those numbers is prime, so I'm going to have to break those down even further. 4 can be broken down into 2 times 2, and these can be circled because 2 is a prime number. And 6 can be broken down into 2 times 3. I can circle both of those because those are prime numbers as well. So 24's prime factorization is 2 times 2 times 2 times 3. I've rewritten the prime factorization of 24 above, so we have room to do our prime factorization of 72. 72 can be broken down into 8 times 9. Both of these numbers are composite and they can be broken down further. 8 can be broken down into 2 times 4. 2 is prime, so I'm going to circle that. 4 can be broken down further into 2 times 2. These are both prime numbers now, so I can circle those. 9 can be broken down into 3 times 3. These are both prime numbers, so I'm going to circle those. there's nothing left to write down, to break down, so I can go ahead and write my prime factorization. I'm going to write it up here above the problem. I have 2 times 2 times 2 times 3 times 3. Now remember, the next step is I want to see what they have in common. I can circle a pair of 2's, another pair of 2's, another pair of 2's, and I have a pair of 3's. This last 3 I will not circle because there's nothing that I can pair it up with. I'm now going to go ahead, and since I have a pair of 2's, remember I only write the number once. I have a pair of 2's, I have another pair of 2's, I have a pair of 2's, and I have a pair of 3's. Now I want to multiply these all out, and I can follow the order of operations. 2 times 2 is 4, and I bring down the rest of what I have left up there and I have not used. 4 times 2 is 8, and bring down that times 3, and 8 times 3 is 24. This is the number that I'm going to go ahead and divide my numerator and denominator by. Now I'm ready to divide. 24 divided by 24 is 1, and 72 divided by 24 is 3. So 24 over 72 is reduced to 1/3. That is as low as it can be reduced. And when I go back and compare it with reducing 24 over 72 by using the greatest common factor method, I see that I got the same thing. Now let's take a look at adding and subtracting fractions with like denominators. When you're going to add fractions, you add the numerators and keep the same denominators. So 1 plus 7 is 8, and the 10 stays the same. We just copy that over. So 1/10 plus 7/10 is equal to 8/10. Then you simplify. Remember, we just talked about that. That's that reducing where you divide by the greatest common factor, or you can find it by using the prime factorization of the numerator and the denominator, just like we practiced just a few minutes ago. So 8/10 could be reduced to 4/5. Let's practice one. 2/9 plus 4/9. Remember, the first thing we're going to do is we're going to add the numerators. And 4 plus 2 is 6. Then remember, the denominator stays the same. You just copy that over. It's 9, so we have 6/9. Remember, you have to reduce if possible. See? Don't forget to simplify your answer if you can. Sometimes here, when you have simple numbers like this, you can just think of a large number that goes into both of those. And in this case, I know that I can divide both 6 and 9 by 3. So 6 divided by 3 and 9 divided by 3. 6 divided by 3 is 2, and 9 divided by 3 is 3. And if I were to do the greatest common factor of 2 and 3, the only thing they would have in common would be 1. Therefore, I'm done. So I've added 2/9 plus 4/9 and gotten 6/9, and I've reduced it to lowest terms, which was 2/3. Now let's take a look at subtracting fractions that have like denominators. It's the same exact thing except as adding, except instead of adding the numerators, we're subtracting the numerators. So subtract the numerators and keep the same denominator. 7 minus 3 is 4. And 8, we just copy that over and keep that denominator the same. So 7/8 minus 3/8 is 4/8. Then remember, don't forget to simplify your answer if you can. So if we were to find the greatest common factor of 4 and 8, we would see that it's 4. And that's why they divided the numerator and the denominator by 4. 4 divided by 4 is 1, and 8 divided by 4 is 2. Again, you also could have used the prime factorization method that we talked about earlier. Let's subtract 12/16 minus 10/16. We're going to subtract the numerators first. 12 minus 10 is 2. And we keep that denominator the same and just copy it over, which is 16. So 12/16 minus 10/16 equals 2/16. Don't forget to simplify your answer if you can. Now remember, you won't always be able to because it will already be simplified or in lowest terms. But always remember to check if you can. The greatest common factor of 2 and 16 is 2. But I also look at this and know that 2 and 16 are even numbers, and any even number can be divided by 2. Plus, I also will at times look and see if one number will go for the other. So 2 can be divided by 2, as can 16. 2 divided by 2 is 1, and 16 divided by 2 is 8. 2/16 in lowest terms is 1/8. Any questions? Make sure you see your teacher. Don't forget to use your notes when you're solving problems as well. Happy solving!